100 billion galaxies with billions of stars, gas clouds, dust particles, planets, moons, and other cosmic objects are only a small part, which is even less than 5% of the total universe's nature. NASA in its website tells us that 95% of this universe's nature is actually formed by invisible matter and energy, consisting of 27% dark matter and 68% dark energy. Two mysterious things that are still being investigated to this day by scientists. Actually, what is dark matter and dark energy? How can scientists detect something that is invisible and call it something that forms and affects our universe? To answer it, let's explore the mystery of this darkness. Everything in the universe that we can see, such as galaxies, stars, planets, living things, and every other object is made up of protons, neutrons, and electrons combined into an atom. All of this is seen in the cosmology of normal matter, or known as baryonic. This normal matter is what contains 5% of the universe's nature, which for us is already very wide and large. But in fact, this normal matter is only the smallest part of the entire mystery of the universe. However, for hundreds of years, humans have been doing research on the universe until scientists realized that there was something wrong in this universe, something that should be impossible to happen. But in fact, the impossibility really happened in the universe we inhabit. The impossibility that scientists mean is the rotation of a moving galaxy at high speed, so that the gravity generated by normal matter cannot hold other galaxies. And the galaxies should have been separated or even fused for a long time. What happened to scientists was really unthinkable and impossible if viewed from a scientific point of view. They did research to find the answer, to give us a little insight at this time, that there is something that we can't see, but something is working to give an influence that can shake the universe and unite other materials in an unexpected way. To simplify it, we can take an example from the point of view of standard physics. Imagine if the stars on the edge of a spinning spiral galaxy should move much slower than the stars near the center of the galaxy, because the influence of gravity that moves them gives different forces based on their range. But the strange thing is, from the results of the observations, it is seen that the stars actually orbit at a speed that is less than the same, not affected by the point of their existence in the galaxy circle. The result does feel confusing, or it can also be called impossible. But let's make it reasonable by assuming that the stars on the edge of the galaxy feel the effects and the influence of gravity from invisible matter, which is called by scientists as dark matter. The existence of this dark matter was only discovered by astronomers in the 20th century. In the early 1930s, there was a Swiss astronomer named Fritz Zwicky who created the term dark matter when he was studying the galaxy coma, which contains more than 1,000 galaxies. The speed of galaxy movements in a galaxy coma generally depends on the mass and total size of the coma. But in Fritz's observations, he noticed that galaxies in a coma move faster than what can be explained by the amount of visible matter. Observations then developed, and this dark matter was confirmed to exist by an AS astronomer named Vera Rubin. In the 1970s, when Vera was learning how galaxies could rotate, Vera and her colleagues found that galaxies may contain invisible mass made of dark matter. Scientists today argue that dark matter is in a structure that is shaped like a wide net that circulates throughout the universe and attracts most of the normal matter. Nowadays, although with increasingly advanced observation technology, we are not able to observe this dark matter directly. Dark matter becomes a form of matter that does not emit or absorb light and electromagnetic radiation, so that it cannot be seen by our telescope at all and is very difficult to detect with today's research instruments. However, scientists have estimated that this dark matter accounts for about 27% of the total mass and energy of the universe. They also believe that dark matter exists due to the effect of gravitation, and like normal matter that occupies space and holds mass, dark matter does the same thing, Unfortunately, because we still have limited research instruments, our scientists still can't make sure what actually forms dark matter. From the existing theories, dark matter is usually made up of several types of particles that have not yet been identified, and these particles seem to rarely interact with normal matter, so it is difficult to find. Other information that can be found from dark matter is the fact that dark matter can cause optical illusions or light curvature of objects farther behind it, where this phenomenon is also known as a gravitational lens, which helps astronomers to measure the mass of dark matter in galaxies. A simple picture can be imagined if we are looking at a playground from a distance. In the playground, there is a long and slippery slope. Then when the light from the lamp runs behind the playground about the slippery slope, the light will turn and form a strange and large pattern. Outside space, we can find things similar to dark matter. There are very large celestial objects, but we can't see them, namely dark matter. Light from a galaxy that is far away, when passing through this dark matter, the light will turn and be distorted, similar to streetlights that turn when it comes to slippery slopes. So the image of the galaxy that we see may not be its original shape, but has changed due to the influence of this dark matter. In short, a strange image of a galaxy with a ring and light curvature can occur because there is a very large and invisible celestial object that deflects light from a farther galaxy. In addition, to find the existence of dark matter, we can find it through a small fluctuation in the cosmic background radiation, which is the remaining light from the Big Bang explosion. By studying this light, we can see how matter is distributed or spread in the universe from the beginning. It turns out that the distribution of matter is not in accordance with what we expect if there is only matter that we can see, because there is something missing called dark matter. Matter that has not yet been determined what it is actually made of, but there are many theories explaining it. The most popular is the exotic particle theory, which assumes that perhaps this dark matter consists of very strange, small particles, different from the particles we know every day, because these particles do not interact with light but still have gravity. In addition, another popular theory is the modification of the theory of gravity, where in this theory there is an assumption that perhaps the theory of gravity that we have learned so far is not entirely true, because there may be other types of gravity that work on a very large scale, such as in the galaxy. In an effort to find the truth about how dark matter can form, scientists are actually doing various kinds of research. One of them is the search for dark matter particles using the Large Hadron Collider, or LHC, a giant machine used by scientists to hit subatomic particles at a speed close to the speed of light. The purpose of the creation of this LHC from the beginning was indeed to study fundamental particles that form the universe and test the theories of physics. The LHC itself is a 27-kilometer-long circular cavity located underground in the Swiss and French borders. The wall of the cavity is covered by thousands of superconductor magnets that are very strong, which function to accelerate and direct moving particles in the cavity. In addition to the LHC, scientists also learn the light from the galaxy by using advanced telescopes to observe the light from distant galaxies, so that they can find clues about the existence of dark matter. If one of the efforts made by these scientists is successful, then we will get a much better understanding of the mystery of dark matter, the composition of the universe, and especially about how galaxies in this universe can unite. Although dark matter feels quite mysterious, dark energy will remain even more mysterious. In the 1920s, astronomers, including Edwin Hubble, found that galaxies seem to be far from the Earth, which shows that the universe is actually developing, and the farther it is, the faster the galaxies are moving away. This fact explains that the rate of expansion of the universe is actually not constant, but rather faster, which means there is a force that opposes gravity and pushes the universe to develop faster. This force is what we call dark energy. If dark matter is a fuel that makes galaxies form and accumulate, then dark energy is an accelerator that pushes the universe to continue to develop faster. Dark energy is very different from matter, both normal matter and dark matter. Matter has mass and occupies space, while dark energy actually fills the entire space and has no mass. If dark matter pulls objects from one sky to another, dark energy actually pushes it away. What unites dark energy with dark matter, other than the fact that both are invisible, is the fact that the origin of dark energy is still a mystery. There are several theories proposed by scientists trying to determine the source of dark energy. One of them is the cosmological constant, which is a concept in physics introduced by Albert Einstein to explain a static universe. However, after finding that the universe was actually developing, Einstein referred to this concept as his biggest mistake. In a simpler term, the cosmological constant is energy attached to a vacuum. Imagine a vacuum as an empty city. According to quantum theory, even in the most perfect empty city, there is a continuous energy fluctuation. This energy is called vacuum energy, and the cosmological constant is the size that describes the density of this vacuum energy. If related to dark energy, the cosmological constant provides the simplest explanation to understand it, because the cosmological constant gives us information about the force of gravity, causing the universe to continue to develop faster. However, although this cosmological constant provides the simplest explanation to understand dark energy, there is still a problem that cannot be solved by scientists, namely the value of the cosmological constant, which is very small compared to the value predicted by quantum theory, which is called the fine-tuning problem. In addition, the nature of the vacuum energy in the cosmological constant and how that energy is related to gravity is still not fully understood. For that reason, another theory was proposed, such as quintessence, which has a dynamic nature and changes over time and space. This means that the quintessence effect on expansion or the evolution of the universe can change over time. Quintessence is also described as a scalar field, similar to the Higgs field that gives mass to particles. This scalar field has a complex energy potential that allows the energy density to change over time. This theory was proposed because the quintessence model offers greater flexibility in explaining cosmological observation data compared to the cosmological constant model. Some observation data also show that the speed of the evolution of the universe may not always be constant. Therefore, the quintessence model can explain a more complex dark energy evolution, such as being able to explain why the universe experiences an expansion rate, then be able to solve the fine-tuning problem faced by the cosmological constant model. And quintessence can also be associated with particle physics theories, such as superstring theory or quantum field theory. Unfortunately, this quintessence model also has challenges in using it, starting from a more complex reason and because it is less reliable, because it does not have strong observational support, such as the cosmological constant model. There is still another theory that is proposed as an effort to find out the origin of dark energy, namely the modification of the theory of gravitation, which is used to explain the speed of the evolution of the universe without involving dark energy. But this theory is less popular than the previous two theories. In 1998, two independent research groups announced that they had measured the cosmic expansion at a higher precision level and found that the expansion was happening faster. Now, how can we determine the existence of dark energy? Astronomers have measured the expansion of the universe using a white dwarf explosion, which is a remnant of a star's core that has run out of nuclear fuel and has shrunk into a very dense object. This explosion is also known as the supernova. This explosion is called the standard Lilin because the peak brightness is very consistent to measure the distance of galaxies, which leads to the discovery of dark energy in 1998, where galaxies far show that the universe not only expands, but also does it at a speed, which is a phenomenon that can only be explained by the existence of dark energy. This supernova can occur when a white dwarf star slowly pulls matter from its companion star. Then when the white dwarf reaches the Chandrasekhar limit, or about 1.4 times the sun's mass, the pressure inside the star will no longer be able to withstand gravitation, thus triggering a nuclear fusion reaction, which is out of control and causes a terrible explosion, which we call a supernova. In addition to this supernova explosion, dark energy is also found through CMB, or cosmic background radiation, which is a remnant of the Big Bang explosion. By studying the fluctuation in CMB, scientists can calculate the amount of matter and dark energy in the universe. The use of baryon acoustic oscillation can also be used to find dark energy when using sound waves formed in the early universe. By studying this wave, we can find out the composition of the universe. So far, the discovery of dark energy has challenged human science to understand gravity in the universe. Dark energy is said to determine the fate of the universe, because if dark energy continues to dominate, this universe will continue to expand forever and make it colder, emptier, and worse. Our universe contains a mystery that is much darker than the darkest night. Dark matter and dark energy, two mysterious components that dominate the cosmos, have long confused scientists. Although we know the existence of both of them from strong gravitational effects, their basic nature is still unclear. Current research involving underground detectors, space telescopes, and particle accelerators aims to reveal the mystery. However, understanding the fundamental nature of dark matter and dark energy is a big challenge that can change the way we view the universe as a whole. Further discovery in the study of dark matter and dark energy will not only be a basic question about the universe, but can also open the door for new discoveries in physics. By continuously exploring the darkness of the cosmos, scientists hope to find clues that can reveal the true nature of dark matter and dark energy. This discovery has the potential to revolutionize our understanding of the universe and bring us to a deeper understanding of the origin and fate of the cosmos. Dark matter and dark energy are two mysterious components that dominate the universe. Although we do not fully understand the basic nature of the two, intensive research is being done to reveal this mystery. By using various tools and techniques, scientists continue to try to crack the puzzles that have long confused. Discoveries in this field will not only answer basic questions about the universe, but also have the potential to open the door for new physics and change the way we view the world. All efforts to find the answer to the mystery of dark matter and dark energy have shown us just how little we know about the universe. Although we have made great progress in science, the universe still holds many secrets. Dark matter and dark energy are just two small examples that show that the universe is much larger and more complex than we imagined before. The matter we see and feel every day is only a small part of the total mass and energy of the universe. This discovery also raises the question of the possibility of life elsewhere in the universe. If most of the universe is made up of matter and energy that is very different from what we know, then the possibility of a very different life form is also open. The discovery of dark matter and dark energy makes us reflect on our position in the universe. If we are only a small part of the universe, which is very large and complex, then we may have to revise our view of the importance of humans in the universe.